Welcome back. Um, uh, this problem, let me explain. You have multiplication, you have division, and you have modulus operators. You are not supposed to use any of these. Instead, you have to use either plus, minus, or bit manipulation, simply bits to do a division operation of two numbers. Let you have a dividend, you will have a divisor, and those will give you a result. So these operations you have to do, but you cannot use any of these, and you have to use only these things. You can do any programming constructs, but you are not allowed to use multiplication, division, or modulus operation. You can use the rest of anything you wanted. So how you go with this problem? So division is basically a kind of scaling. Suppose you have this is the whole dividend. When you do some kind of scaling with a divisor, your result will be ideally the number of times your divisor will flow inside your dividend. This will be the unit divisor. So this unit can be scaled and replicated 1, 2, 3, 4, 5 times. So this 5 will be your result. See, you have your divisor. You wanted to test how many times it will flow inside your dividend. So that will give you a result RES. So this problem is very typical. So you cannot use any of these operations as well. So the approach we are going to take here is a kind of binary bitwise operation. Bit is basically the powers of 2. So any number we can represent it as a power of 2. So you will have a 2 power p, 2 power p minus 1, etc. up to 2 power 0, which is 1 basically. So when a divisor comes to you, you can consider this as a unit. Unit means 1. So you made it as a unit. So you will start checking what all powers of 2 are available in your result. So how will you go with that? So you will scale your divisor with powers of 2. So initially you have a scale 1, then you will make it 2. It is less than your dividend. Then you will make it 4, which is less than your dividend. When you make it 8, it goes outbounded. So 8 is not the number you are looking for. You have 2, 4, which is power of 2 power 2. This is the one power you will be looking for. When you cover your unit multiplied by this power, you will be covering almost this length. Still you have a single portion left over here. So this portion is still left. So you will again start with a single unit over there, single unit of your divisor. That itself will cover the rest of the portion. That will add a 2 power 0 to your answer. So you have 2 power 2 and a 2 power 0. So your net answer will be this 2 power 2 plus 2 power 0. It will be 5. This is the answer you are looking for. That will be your result. So you have 2 of the powers of 2 contributing to your answer. So this is the thing you have to program as answer of this problem. So I will explain the problem in bare sentences. You have to divide two numbers. You cannot use multiplication, division, or modulus. If there are some extra portions over here which comes as a fraction, we can simply remove the fractional parts, which is not complete which does not have enough length as of your divisor. So hope you got this problem. You can read the exact problem in the link provided in the description. So let me give you a gist of how to program it. So you have your dividend and you have your divisor. You have to divide it. So first we will convert dividend and divisor into a positive number so that the operations will be easier to do. A positive number, long absolute dividend. Divisor, long absolute divisor. I pick long because we have to deal with interim and intermax. That's why overflow may be there. So that has to be handled. Now you need to find signature of your answer. That will be like XOR of dividend greater than 0. Divise greater than 0. If this is the condition, both have same sign, then it will give you a 0. Same sign will give you a 0. Opposite sign will give you 1. When it is opposite sign, you have division will be a negative number. Your result of a division will be a negative number. Otherwise, it will be a 1, a positive number. You have your answer. Y divisor less than or equal to dividend. You need that scale of 2. This will be your scale, multiplier or scale, whatever you go. Initially it's set to 2 power 1 because divisor is less than 2 power 0. That means 1. Divisor is less than dividend. 2 power 0. Then you have a temporary variable for taking the multipliers of your divisor, while temporary variable multiplied by 2. That means left shift less than or equal to dividend. Dividend. Multiply temporary variable with 1. Multiply your scale with 2. Both are actually multiplication with 2. Left shift does multiplication with 2. So now you have a factor of power of 2 which will be contributing to your answer. That will be stored in M. So add that into your answer. Now you have a portion of your dividend recorded in this temp. Reduce that portion from your dividend. This will give you answer you're looking for. You have to multiply it with your sign. Answer. Well, let's check the solutions. There is one problem. We have 4 test cases. 10 divided by 3, it's 3. Int min divided by -1. It is possible 214748368, which is a number beyond int max. It's an overflow case that has to be handled separately. Otherwise, the int min divided by 1, which is basically int min, and 3033 divided by 3, which is 1011. So that only a case which came as edge when dividend equal to int min and divisor equal to -1 to return int max. This is kind of a ceiling, a fake answer, because problem specific. You need not have this at all here because I copied it. I copied this problem from somewhere. They had to constrain their solutions within int. So int max is the largest possible right apt answer which you can give for a case like this. Yeah, that got corrected. Thanks for listening.